We previously talked about coarse coding. Today, let's look at a computationally efficient way to perform coarse coding, tile coding. By the end of this video, you'll be able to explain how tile coding achieves both generalization and discrimination, and understand the benefits and limitations of tile coding. Tile coding is a specific type of coarse coding. Tile coding performs an exhaustive partition of the state space using overlapping grids. This is perhaps best understood through an example. Let's revisit our fish friend who lives in a two-dimensional continuous state space, the pond. Unlike coarse coding, which uses arbitrary shapes, tile coding uses squares. What's the most convenient way to lay out a bunch of squares over a space? It's a grid. Let's call this grid a tiling. So far, using this is just state aggregation. Larger tiles will result in increased generalization. Although the ideal tile size depends on the specific problem, it's generally a good idea to use larger tiles. To improve the discriminative ability of our tile coding, we can put several tilings on top of each other. Each tiling is offset by a small amount. Offsetting each layer of tiling creates many small intersections. This results in better discrimination. In practice, it is useful to use a large number of tilings. For one tiling, generalization only occurs within the square, but with multiple tilings, updates in this state generalize to these other states. The generalization in this case is diagonal. If we had used random offsets, then the generalization would be more spherical and homogeneous. This is discussed more in the textbook. Let's talk about how to control the generalization properties further. We can do this by creating a grid of rectangles rather than squares. An efficient way to do this is to scale each dimension of the state space. The environment appears to have gotten squished here. Actually, layering squares over this squished environment is like laying rectangles over the unsquished environment. By using rectangles, we can control the broadness of the generalization across each dimension of the state space. Tile coding can represent a wide range of functions, but its utility does not end there. Tile coding is also computationally efficient. Since grids are uniform, it's easy to compute which cell the current state is in. Due to its computational efficiency, tile coding can be used to quickly run preliminary experiments in low-dimensional environments. However, as the number of dimensions grows, the number of required tiles grows exponentially. As a result, it can be necessary to tile input dimensions separately. Whether or not input dimensions can be treated independently depends on the specific problem. In this video, we talked about coarse coding and how it is a generalization of state aggregation. See you next time.